Coach Fred here, and today I'm going to be just going over a review of basic trig equations and their structure. I've been using the word structure a lot in my videos and in my class, and it's dawned on me that maybe you don't understand what I mean when I use the word structure. So all equations follow a specific structure. The way they're written tells us some things about it. For example, if I gave you an equation in the form y equals 2x plus 6, that's a linear function in slope-intercept form. The structure is that the value in front of the x represents the slope, and the 6 represents the y-coordinate of the y-intercept. That's the structure of it. That structure, slope-intercept form, is never going to change. Sure, we could write it as y equals 6 plus 2x, but it's going to have all those pieces in its structure. All right, so when we're talking about trig equations, they're all going to actually follow the exact same structure, and we're going to solve them differently. But the structure is going to be the trig function, so sine, cosine, or tangent for now, times the angle equals the ratio. So what I mean by that is, say it's sine, it would be like sine of 43 equals the opposite, so say 2 over the hypotenuse. Say the hypotenuse is what we're looking for, and it's a variable. Or it could be sine of x equals 5 over 6. Or it could be cosine of y equals 12 over 15. That's the structure. Again, the trig function times the angle equals the ratio. All right, well, let's look at the 4 ways I could actually ask a question and how you'd solve it. So I'm not always looking for an angle or a side in a triangle, but that's what trig helps me find. In a right triangle, trigonometry can help me find missing angles and missing sides. There's also other ways to do that, but trig lets us do it as long as we have 2 parts of the triangle, an angle and a side, 2 sides. All right, I could ask you a question, so we'll call it type 1, where I just actually ask you for the ratio. I give you a triangle. Maybe I give you a side 5 and a side 13, and I ask you to find tan, I'll put an x here, find tan x. Okay, find tan x. When I ask you for the tan of x or the sine of x or the cosine of x, I'm asking you for the actual ratio. All right, so we know that tan comes from TOA, in the SOHCAHTOA, so the ratio is the opposite leg over the adjacent leg. Okay, so in reference to this angle, because x is the reference angle, the opposite is 5. Darn, I'm missing the adjacent side. Well, because you have 2 sides of the triangle, you can find this third side either using a Pythagorean triple, which 5, 13 would tell me it's a Pythagorean triple in this case, or the Pythagorean theorem. So this one happens to be a 5, 12, 13. So I'm going to put in the 13, and so then tan of x equals the ratio 5 over 12. All right, so again, when I'm asking you to find tan of x. All right. Type 2 and 3. So type 2 would be I actually ask you to find x. Okay, so I give you that same triangle, 5 and 13. We found this to be 12, and I say find the measure of angle x. Okay, I'm trying to find a measure of an angle in the triangle. Okay, so now we write our trig equation. So we could use any of the trig functions here. I'm going to stick with tan. So tan x equals 5 over 12. But now this is when I have to think a little bit. I need an angle. When you need the angle, you have to use the inverse function because that ratio is allowing us to work our way back to the angle. We have to undo the ratio to find the angle. So need angle, use inverse. So in our calculator, we press second tan and we get the inverse symbols. That's what inverse means. Inverse tan is tan raised to the -1, 5 over 12. And we grab our calculator. Again, on our calculator, we're going to press second tan. That will appear. So second tan 5 divided by 12, and we get 22.6 degrees. It's an angle, so it's degrees. All right, let's look at finding sides, type 3 and 4. Type 3, type 4. I give you, again, a right triangle, okay, and I give you an angle measure of, say, 43 degrees, and I give you x, and I give you, I don't know, 15. And the question says, find x. Okay, so I look, I have a right triangle, number 1, because you can't do right triangle trigonometry without a right triangle, and I'm trying to find a missing side. So I can only use trig if I have 2 parts of the triangle already given to me. And I gave you an angle and a side, so I can use trig. So I use the structure. Again, I pick the trig function I'm going to use. We call this the reference angle. In reference to that angle, I want the opposite. I have the hypotenuse. So that's my SO, opposite hypotenuse of SOHCAHTOA. Okay, so I'm going to write the structure, the equation, okay? So sine of the angle equals the opposite over the hypotenuse. Done. Equation done. Now I've got to solve the equation. So to solve the equation, we're going to clear the fractions by multiplying both sides of the equation by 15. This gives me 15 times sine 43 equals x. I grab that handy dandy calculator and I type in 15 sine 43, and that gives me 10.2 equals x. And remember, in our class, we're going to round to the nearest tenth, but read the directions of the question. Okay, if it says round to the nearest whole number, that would be 10. Okay. All right, type 4 is similar, slightly different. I give you a right triangle. I give you an angle of, say, I don't know, 31 degrees. And I give you a side of, say, maybe 5, and I ask you to find the hypotenuse. Okay, so I have a right triangle. I have an angle, 31, and I have a side 5. I have 2 parts of that triangle. That means I can find that missing side. So I use the structure. I decide which trig function I'm going to use. So I have my reference angle of 31. In reference to that angle, I have its adjacent side. I want the hypotenuse, so I'm going to use cosine. All right, so I write my equation using structure. Cosine 31 equals 5 over x. Bummer! X in the denominator. I follow the same process, guys. I clear fractions by multiplying by the lowest common denominator. In this case, it's x. So I multiply both sides by x. Now remember, x is being multiplied to cosine 31. So this leaves me with x times cosine 31 equals 5. I'm solving for x, so I just divide by cosine 31. So I grab my calculator, and I have 5 divided by cosine of 31, and I get 5.8. All right. So those are the 4 basic types of equations. Now, remember, I can find right triangles in other places. I can find right triangles in an isosceles or an equilateral triangle, right? I could drop an altitude. Remember that in an isosceles triangle, it would cut the base into 2 equal parts. I know it also bisects this angle. So I might have to use what I know about an isosceles triangle to help me. I know that I have right triangles in trapezoids. Sometimes they're isosceles trapezoids, sometimes not. But if I drop an altitude, I have a right triangle on both like wings of the trapezoid. I can even draw a right triangle in a circle. I could draw a right triangle by connecting 2 radiuses. So there's lots of ways for me to get a right triangle. And that means that if I have at least 2 parts of that right triangle, I can use trigonometry to find missing sides. It's just another way to add to our toolbox of triangle information. All right, guys, have a great day.